In this video, I'm going to show you how to solve quadratic equations by completing the square. Now, we already know how to complete the square on a quadratic expression, but now we will see how to use that technique to solve a quadratic equation. So here we want to solve x squared plus 6x equals 1 by completing the square. And to do that, we need to start by completing the square on the expression on the left-hand side. So remember how we do that is we take that x coefficient, the 6 here, and we have to do some operations with that coefficient to figure out what we add. So what we do is we divide that 6 by 2, we take 6 over 2, and then we square the result. So 6 over 2 squared. 6 over 2 is 3, and then 3 squared is 9. So 9 is the number that we have to add to the left-hand side in order to complete the square. But remember that this is an equation that we're working with now, so we're going to have to add 9 to both sides. So let's go ahead and write this again, but add 9 to both sides. So x squared plus 6x, and then plus 9 on the left-hand side equals 1, and then plus 9 on the right-hand side. Okay. So now this is the same kind of equation, it's equivalent to the original equation, but now we can go ahead and factor the left-hand side into a perfect square. So let's go ahead and do that. It's x plus what squared? Well, what number squared makes 9? It's 3. X plus 3 squared. And now let's simplify the right-hand side. 1 plus 9 is 10. Great, now to solve this equation, we can simply take a positive or negative root of both sides and then solve for x. So let's go ahead and do that. Taking positive negative root, we get x plus 3, no squared this time because positive negative root cancels out the square. That equals plus or minus root of 10. Now to solve for x, we can just subtract 3 from both sides and get x equals negative 3 plus or minus root 10. And there we go, we've got it. There's our solution for x. Alright, here's another example. Let's solve this equation 3x squared equals 5 minus 2x by completing the square. Now this example is a little bit trickier than the previous one because now we've got x on both sides of the equation. We've got an x squared on the left-hand side and an x on the right-hand side. And to complete the square, we need all of the x's to be moved onto a single side of the equation. So why don't we just move this minus 2x over to the left-hand side by adding 2x to both sides, cancel that out. So we'll have 3x squared, then plus 2x equals 5. Okay, this is better now because we have all of our x's on the left-hand side. So when we complete the square, we can get a perfect square on the left-hand side and then just a regular number on the right-hand side, and then it'll all work out because the x will be isolated within that perfect square. Okay, so now we complete the square on the left-hand side here. But hold on, there's again another barrier in our path. The barrier is that the leading coefficient on the x squared is 3 now instead of 1, and we're used to completing the square with 1 as the x squared coefficient. So what do we do now? Well, why don't we transform this equation into an equation with 1 on the x squared coefficient? We can just divide everything in this equation by 3. So let's do that, divide by 3, and then we just get 1 as the x squared coefficient, so just x squared, then plus 2/3 x equals 5/3. Great, so now we can complete the square as usual. The x squared coefficient is 1, so we can go ahead and look at that x coefficient, 2/3. We divide that by 2, so 2/3 divided by 2, and then square that, and that'll be what we want to add to both sides. So let's go ahead and compute this. 2/3 divided by 2, well, half of 2/3 is just 1/3. So that's 1/3 squared, and 1/3 squared is, well, 1 squared is 1, so that 1 stays on the numerator, then 3 squared is 9. So 1/9 is the number that we want to add to both sides. So let's go ahead and do that. Add 1/9 to both sides. We get x squared plus 2/3 x, and then plus 1/9 is equal to the right-hand side. We have 5/3 plus 1/9. All right, great. Now we can factor that left-hand side here. This factors into x plus something squared. What's that something? Well, whatever that something is, when we square it, it has to come out to 1/9, so it's got to be 1/3, x plus 1/3 squared on the left-hand side, and that is equal to the sum of these two fractions. Okay, so why don't we add these two fractions? We'll take that and work it out on over here. That way we can just stick our result back into the equation here. So 5/3 plus 1/9. Okay, remember, adding fractions, you have to have a common denominator. The denominators have to be the same. But now we've got 3 and 9 in the denominator, so we need to convert these two fractions to have the same denominators. And we can do that by multiplying each of these fractions by the same number on the top and bottom. And we can do that by finding the least common multiple between 3 and 9 here. What's the least common multiple? Well, 9 is a multiple of 3. So we can just multiply this fraction 5/3 by 3/3 to get to a denominator of 9, because 3 times 3 makes 9. So let's go ahead and do that. 5 times 3 is 15, then over 3 times 3 is 9, then plus 1/9. And okay, that's nice. Now we have the same denominator. We can just add straight across. So 15 plus 1 is 16, and then that's over 9. So 16/9 is what we can then stick back in for the right-hand side here. That'll be 16/9. Great, now let's continue with solving for x here. So to get rid of this squared, we just take plus or minus square root. So we get x plus 1/3 equals plus or minus square root of 16/9. And that simplifies nicely. We'll have x plus 1/3 equals plus or minus root of 16 is just 4. And then root of 9 is just 3. So x plus 1/3 is plus or minus 4/3. That leads us to solve for x, just subtract 1/3. X equals negative 1/3 plus or minus 4/3. And we could leave it like that, that's perfectly fine, but it'd be nice if we could simplify this a bit further. Because these fractions will combine nicely, we can find the actual two answers here in very simplified form. So let's break off a section here to do that. So one of the answers will be x equals negative 1/3 minus 4/3, and the other answer will be, or x equals negative 1/3 plus 4/3. Okay, so we can just add these fractions. In this case, we get x equals, well, negative 1 minus 4 is negative 5. So negative 5/3, or x equals, what's negative 1 plus 4? Well, that's just 3. And 3/3 is just equal to 1. So x equals 1 is the other possibility. So here we go. These are our two solutions. X equals negative 5/3 or x equals 1. All right, here's a final example. We want to solve this equation 2x squared plus x plus 2 equals 0 by completing the square. And this is pretty similar to the previous problem. We first want to rearrange our equation so that only the x's are on one side alone. So let's move just all the x's to the left-hand side. So get that 2 out of there to the right-hand side. So we'll just subtract 2 from both sides. We'll get 2x squared plus x equals 0, then minus 2, which is negative 2. Okay, and now the leading coefficient here on the x squared is 2. We want to get that down to 1. So we'll divide everything in this equation by 2. Divide everything by 2. So 2 divided by 2, that just goes down to 1. So we just have a single x squared. And then plus this right here is 1x right now. And then if we divide that by 2, we get a half x. So x squared plus a half x is equal to the negative 2 divided by 2 is just negative 1. All right, now we're in a good position to actually complete the square on this left-hand side. So take that x coefficient, 1/2, take that 1/2, then divide it by 2, and then square it. So what's that? Well, what is 1/2 divided by 2? We can just write that as 1/2 times a half. Dividing by 2 is the same as multiplying by a half. So we'll do that and square it. That's easier to compute. 1 times 1 is 1, and then 2 times 2 in the bottom is 4. So that's a fourth, then squared. And a fourth squared, 1 squared is just 1, and then 4 squared is 16. So 1/16 is the number that we want to add to both sides. So let's go ahead and write this down. Again, add 1/16 to both sides, get x squared plus a half x, and then plus 1/16 is equal to -1, and then plus 1/16. All right, next up, as usual, we'll factor the left-hand side here. So x plus something squared. What is that something? Well, that something squared has to be 1/16, and 1/16 comes from 1/4 squared, so it'll be 1/4. X plus 1/4 squared is equal to, let's go ahead and do that computation for the right-hand side. Again, we'll just move it over and do it and stick it back in. So -1 plus 1/16. To add this, we need a common denominator. Why don't we turn this -1 into a fraction? We can write that as -16/16, and then plus 1/16, and suddenly that becomes much easier. What's -16 plus 1? Well, -16 plus 1 is -15, and that's over 16. Okay, so we can stick that back in to the right-hand side here, -15/16. Now, to cancel out that square here, to solve for x, let's go ahead and take the positive negative root of both sides. So x plus 1/4 is equal to plus or minus root of -15/16. But hold on a second there. There's a negative in the root now, and we can't take the root of a negative number. It doesn't come out to a real number. So on this right-hand side, it's not a real number. So as a result, there is no real number which we can have as a solution for x. So our conclusion is then just there's no real solution to the equation. And that's what we end up with. Great, so now we know how to solve quadratic equations by completing the square. And in the future, we'll continue to learn more about the relationships between the coefficients of quadratic equations and the solutions to those equations.